Okay, welcome Nick and Marilyn, Genevieve and Roberto and Sophia and Braulio and Heather and Sammy. Thanks for coming. This is the week 4 webinar. And let me share my desktop and I'll talk about what we're going to do. Okay, so the plan today, you're going to notice it's a much smaller plan than usual. This should be a lighter webinar than usual. I think you'll feel that. We've been going kind of long the last few weeks because I've been getting you, all set up for the project and doing all kinds of double chapters and stuff like that. Whereas today's a lighter week in terms of the chapter content. But I'll start out as always with Q&A. Any questions you might have, be happy to answer. And then we're going to get into the standard normal distribution, which we've kind of talked about a little bit already, but now we're going to get into depth. We're going to get into detail. And the good news is, or bad news, however you want to look at it, is the math is hard, really hard. Why is that good news?
We don't have to do it.
Calculator?
Exactly. If the math is really hard, then you're not responsible for it because you can't even do it with calculus, with regular calculus. It's harder than that, just to let you know. For those who've had calculus, it's a non-integrable function. So it's a tough one. It can be done, and that's my job. But you're going to need to be able to use a calculator, and you can use the one I created because that's what's going to be in the test. And if there's something you don't like about it, let me know, and I'll do whatever you want. You just have to ask. I mean, basically, it won't read your mind. I haven't figured out how to make a calculator that reads your mind, so you do have to type the numbers in. Maybe you can tell me how to do that. So we're going to do the standard normal distribution. And then after doing the standard normal distribution, we're going to do the general normal distribution. So the main difference is the standard normal distribution has a nice standard deviation and mean, as nice as you can pretty much imagine. Whereas the general distribution has whatever standard deviation and mean it might be. So, but it turns out that it's not any harder to calculate, really. Even by hand, it's hardly any harder, which you'll never do by hand. But with a calculator, it's really not any harder. Then we'll do some applications. And that's the plan. Again, it's a short list because there's not too much to talk about, but I'll have some examples. So there's, it's not like we have nothing, so I'm skipping the webinar. But I want to let you know about two main things that are coming up in not too long. The first one is Thursday at 8 in the morning. What must be done if you want help by Thursday at 8 in the morning?
Rough draft?
Yeah, your project rough draft. And if you wait until 7:59 in the morning on Thursday, it might be Saturday before I get back to you. Just let you know that, because the papers are usually like somewhere between 7 and 10 and 12 pages. There's always a few that are shorter and they usually aren't good grades. And then there's some people that just go crazy and do a 22-page paper, and that's not necessary, but if you feel like it, you can do that. I'll read it. But the point is, I will read all the pages, and it's a big group. So if there's 12 of you all sending me a 10-page document, that's 120 pages to read and write suggestions for. So it does take me some hours, but I do have that Thursday pretty much set to do that. So I'll do my best to get as many done as I can. But I do want to let you know in advance that things could happen. And then the absolute disaster could happen. Anyone know, especially if you're from Tahoe, what's going to happen in the middle of the week?
Storm.
2 to 6 feet of snow.
I'm freaking out.
which is going to be beautiful unless we lose internet.
Yes.
So I will let you know. I think and this should be obvious. I don't have to tell you this. If I don't have internet, I can't email you. And I can't let you know any comments and stuff. But hopefully that won't be a problem. But if you've lived in Tahoe, you know what I mean when you're expecting, possibly 5 feet of snow. especially at the higher elevations, we could lose power and internet. So hopefully that doesn't happen. But if it does, I apologize in advance, at least for having the webinar in a day where there's no problem. So that's the good news. So anyway, plan on that. Be ready for that, because especially if you live in Tahoe and other places too. I think a lot of Californians getting a big storm, not just us. Other people getting rain instead of snow. So that's just a note. Then on Sunday, what's the major thing do?
Project.
The project. Okay. Does that mean you should do it on Sunday? Definitely not. Okay. You should have it basically done on Thursday, so that, done on Wednesday. And then there'll be some minor modifications to fix when I get back to you, hopefully on Thursday. Okay. And the idea is the minor modifications shouldn't take more than a day for you, if they're minor. And that means you could turn it on Friday or Saturday. Okay. I wouldn't recommend waiting until the very last minute. Things go bad if you wait till the end. So you want to get it done early. It's a smarter thing to do. Okay. And then next week, okay, I know that's like forever for you guys, but it's time to start thinking about it. So next week, which is Thursday, Saturday, and Sunday. Actually, I shouldn't say that. Thursday, Saturday, or Sunday is a better word, because you get to choose what's going on.
Exam 1.
Yeah, exam 1. So I lighten up this week. Okay, so I'm lightening up this week in terms of homework and stuff, so that you can get ready for all this other stuff you got going, big time. And that's where, if you're worried about your grade, project 1, exam 1, those are biggies. Okay, if you miss a point or two on the discussion post or an assignment, that really hardly changes your grade at all. Okay, in one assignment. But if you do poorly on the exam, it's very bad. So you want to make sure that you are ready for it. So on next week, on Tuesday, I believe, we'll have a webinar, and a good portion, maybe a half or so of the webinar, maybe a third, we'll be getting ready for exam 1 to talk about it, kind of last minute stuff for exam 1. Some of you will take it Thursday, some later, because it's your choice. You take it one time. Okay. And also the project. One of you from the group turns in the project, the other don't. Make sure your names are on the project. So there's a few absolute requirements for the project. Names, because remember, if one person is turning it in, then the rest of your group needs to get credit for it. And you put their names on it, then I make sure you credit, and everyone gets the same score, by the way, in the group. So, don't be a slacker. One thing is, your project probably won't go as well. And the other is you're going to make enemies, which is never a good thing in life. So, be good to your partners and work together. Don't wait till last minute, make sure you're a team. So that's really important in terms of doing the project right. So those are big things coming up. This is kind of a big time in the quarter in terms of, coming up stuff in the next, 13 days or so. So are there any questions?
I had a question about the format of the paper. Do you want just like a standard stats or scientific paper with an abstract, intro, methods, results, conclusion, whatnot?
I'm not. One thing, this isn't an English class. So, no, it has to be readable. If I can't read it, that's not good. So I'm not a big stickler for that kind of format, but there should be some kind of introduction. You can call it abstract, introduction, whatever you want to call it. That's up to you. There should be some kind of conclusion. If you have a different name for it, that's fine too. I'm not too concerned with that. Much more important is that you really show that you fully understand statistics, that you're using, and you fully understand how it can be used by your client. How will it change your client's life? What decisions will your client make for everything that you write about? Okay, for every statistic, for every chart. So that's really what you should focus on. Don't worry too much about, how many paragraphs in the abstract versus, or should you wait for that paragraph after the abstract? I don't care. I care about content. Okay, but don't just give me 7 bullet points and call it a paper. The other absolute requirement, if you remember, is a snapshot of the statistics columns from the spreadsheet. And that has to be in the paper.
Okay.
So that's one that is important, because that's how I prove that I required a spreadsheet so that this class transfers.
Perfect. Thank you.
Yeah, so that's absolutely necessary. And your names, but that shouldn't be, I shouldn't have to say that too many times. You should have a title, and not project 1, but a title that's tells what you're doing. Does that make sense?
I have a question. For making the histogram, I'm totally stumped at the moment. Am I supposed to fill out the spreadsheet and it creates the histogram from the spreadsheet information?
Yeah, it does it automatically.
Okay.
That was
that's
my
what
job. I coded it.
Good job.
If you're
Thanks.
not seeing it done automatically, that means you screwed up somewhere. Yeah.
Okay,
'cause
perfect.
in fact, as you type, it'll do the histogram.
It does. It does. I noticed that, and I just was wondering if that is the one that we put into the paper.
Yeah, I mean, if you don't like my histogram and you have another histogram, maybe you can do that, but it's not necessary. What's more important is you look at the histogram, you talk about the shape of the histogram, what it tells you, and what decisions the clients are going to make based on the histogram.
Okay,
And-
thanks. Yeah, that's what I was wondering, if we were supposed to, because there's 2, well, histogram makers. I mean, there's the actual spreadsheet, and then there's the histogram maker, which are different formats. So I was
That I
just
have
kind of,
I think I have on the spreadsheet, I have some links to some other ones. And that's because in the past, some of the students had trouble because of some kind of browser blockages. But if you don't have a browser blockage trouble, then there should be no problem.
got it. Okay, thanks for clarifying.
Yeah, so that was the reason why I put those links in, is that's like a plan B kind of thing. Yeah, and it seems like the browser's not blocking it like it used to, but it was for a while. I want to mention another thing, because I did grade your assignment today, your discussion post. And when I make a promise, I always go by it. And I promise that if you did not put in the words many, likely, average, close to, remember those words? Then you lose points.
Me particularly, or
Huh?
are you speaking to me particularly, or the
Oh,
class?
no, I'm talking about the class. It's just about everybody. But I want
I'm
to.
sorry, when you said that, I thought that was referring to our project. I didn't know that was on the assignment.
No, in fact, it's not even part of your project. The project doesn't cover chapter 4. But more important, this is why I'm saying it now, because the assignment is history. More important is next week on the exam. And guess what? My promise will still stand. If you don't put those words, on your interpretation of the expected value, you will lose points on the exam. Okay.
So it was many, likely, close to, and something else.
Yeah. So there's many. So it's kind of, if you do many trials, then it is likely that the average will be close to the expected value. Now, don't just, write that sentence, because that doesn't relate to whatever the question is. You know what I mean?
Right.
But those words have to be there. And you lost points on your discussion board assignment because I promised you would. And part of that is so that I help you get it, so that you get the exam right, which where the points are. Okay, so I figured I should mention that, because so many of you didn't get. I think only one person had all the words in like both classes, both sections, which was a little bit disappointing. Okay, so I put a note in comments. Make sure you read the comments when you get your grade. Don't just look at your score, but read my comments, because I put a lot of comments in. It did take me 5 hours this morning.
But it is true that the discussion,
Yeah, I lost you. You're on mute.
it is true though, discussion points and assignments don't carry much weight overall, right?
Right. All the discussion combined is 10% of your grade. So there's like over 10 discussion post assignments. That means less than 1% per discussion post assignment. And there's 10 points in each. So if you lose 1 point, that's 1/10 of 1% of your course grade. And that's like nothing. Whereas one problem missed on the midterm is like, more than 10% of the midterm. And that's like 3.5% of your whole course grade, something like that. So just let you know, or in the final course grade would be 2% off. So each problem on the exams are much heavily weighted than the assignments and discussion posts. But if you don't learn from the assignments and discussion posts, the exams will go poorly for you. Any questions on that? Again, I want to make sure that you're all set and ready. Okay, you ready for new material? Let's talk about the standard normal distribution. So I want to mention that we've talked about distributions already. See if you can tell me, you can put in the chat box or say it. What distributions have we talked about? 2 of them in particular. What words? 1 word each. Good. Binomial and uniform. Okay, so chapter 4, chapter 5. So chapter 6, we're going to do the normal distribution. On a scale of 1 to 10, I'd say binomial distribution is about a 3 in importance, where 10 being extra super important. The uniform distribution is about a 2. Any guess on what the normal distribution is?
5.
10. So pay attention. If you don't understand the normal distribution, by the end of this course, you will fail this class, because this class is all about the normal distribution. Pretty much everything we do from the rest of this class uses the normal distribution. And as I mentioned, the good news is the math is too hard, which means you're not responsible for the math, but you are responsible for the ideas. Is that clear? And the ideas is just kind of a good idea of the shape and the symmetry, and then how to use a calculator, okay, and how to apply it. So I have a picture. So this is a graph of the normal distribution, and you've probably heard other words for this shape. What other words have you heard for this shape? There's 2 other types, one that you probably don't know, one you have heard.
Bell shape.
Yeah, this is called the bell curve. You've probably heard of that, right? Whenever someone said, you probably heard, oh, do you grade on a curve? That's what this means. Yeah, I figured Meryl would get this one. I shouldn't say no one would get it, because there's one person who knows calculus. It's called the Gaussian distribution, is a kind of a fancier name, but we don't do that in this class. And that's, except other than the spelling, that's right. And the Gauss is probably the most important mathematician of all time. He didn't just do this. He's like the father of so many different parts of mathematics, including statistics. So if you hate statistics, you can get mad at Gauss, right? Because he's the one that came up with it, okay, or came up with a big piece of it. So this is the shape of it. And let's see if you can tell me a word or 2 that we've talked about in this class that describes this shape. See if you remember some of the words we've used. You can put in the chat, you can say it. And don't say normal, because that's what this is. Yeah, it's symmetrical. So it's definitely symmetrical. So if you look at the center of it and call that a mirror, the left and right, the left-hand side is a mirror image of the right-hand side. Does that make sense? What's another word, a statistical word that we've talked about that describes this besides symmetrical. Okay, if no one remembers, unimodal. Do you remember what that means? Yeah, one peak, right? Because remember, una is like unicycle, so it means one. Unicycle's got one wheel. So una's one. And mode means most frequent. So that means there's only one mode or one peak. Does that make sense? And we can see that in the normal distribution. Whereas bimodal is going to look like a camel. It's going to have a couple lumps. Does that make sense? So this is a unimodal distribution, and it is symmetrical about the mean. Okay. Where have you seen this in nature? So it does happen a lot in nature.
Like when they're getting earthquake readings or something?
It can happen, although usually earthquake readings are what's called sinusoidal. If you had trigonometry, they're sine waves. But I'm not going to get into that. That's pretty fancy. This is something you've known since you were a year old, maybe 2 years. If your
Baby
mother-
monitor?
Huh?
A baby monitor?
You didn't know how to read a baby monitor when you were one.
Oh, no.
You ever play at the beach? Do you ever drop some sand down at the beach? What does it look like? It looks like this. Okay. So it turns out that physically, whenever you have things like grains of sand dropping, it's always going to have this shape. So this shape happens in lots of different places. Something that, and this is way too hard for my guess for everybody, but every atom in your body follows the normal distribution in its location. And I'm not going to get into that because it's called quantum physics, but it's everywhere. And I'm just going to tell you it is. Sound good? So you can believe me that that's true. You can't see your atoms, by the way. They're too small. Okay, but normal distribution happens everywhere. But that's all like strange physical stuff, right? Yeah, one-humped camel looks pretty normal. Okay. But it comes up in a much more important way. And that we're going to talk about next week. And that has to do with what's this class all about? You should all know this. It's already week 4. What's the class about? Yeah, statistics. And in particular, statistics mean that you have taken a sample and you're looking at what you can read from that sample. And it turns out that for every sample with a sample size large enough, then the what's called sampling distribution, this is going to be next week, will always be normal. So that means that anytime you ever conduct a study and have a large enough sample size, which isn't that hard, the results will always look normal. Okay, and the word result we'll talk about next week. So just trust me, that's how important this is. It's the distribution. So these numbers, 68, 95, 99, where have you seen those before?
The quartiles? Or
The quartiles.
No, it's on the tip of my tongue. I can't get it out.
It's actually not Chebyshev. Chebyshev is the one that you have to use if you can't use the one that we have, the 68, 95. Yeah, there we go. The empirical rule. The empirical rule. So by the way, that you need to talk about this stuff in your project. Okay. Not all about the normal distribution, but the empirical rule and Chebyshev. You're going to use one of those and not both. So just let you know that the empirical rule was the 68, 95, 99 rule. In fact, sometimes they call it that instead of empirical rule. So just let you know what that says is that for the normal distribution, if your z-score is less than 1 and you want to find out the probability or the area under that curve, then it is 0.68. Okay, and that's rounded to the nearest percent. If you want to find out what's the probability the z-score is going to be less than 2 in absolute value, that's 0.95. And if you want to find out what's the probability the z-score is less than 3 in absolute value, that's 0.99 or 99%. So those numbers come up a lot. And of these three, which do you think is the least important? It's just a guess. Of these three numbers.
99.
9.
Okay, I figured no one's going to guess right. No, 68 is the least important. It turns out the 95 and the 99, those are the biggies. And we'll talk about that in 2 weeks, why those are really important. That'll have to do with what's called confidence intervals. So again, everything we're doing today is going to be used again every week. So in 2 weeks, we'll get all into this 95 and 99%. And that's what 2 weeks is. We'll also get into 90%, but the z-score number is not as nice. Okay, any questions at all on the picture? Okay, so if I asked you, so first thing, let me define something. So the standard normal distribution, let me make it capital. So the standard normal distribution is the normal distribution with mean 0 and standard deviation 1. Because those are like the easiest mean and standard deviation that are useful. 0 is like the easiest number to work with. You can't have a standard deviation of 0 because then there's no variation at all, right? There's no picture. So standard deviation 1 is the easiest number. So that's why we call that the standard normal distribution. Any questions on that? Okay, just a second. Let me make this red so I can highlight it nicely. So the letter we use for the standard normal distribution is Z. Any guess why you use the letter Z for the variable? Here's a hint. It's the only other time we use the letter Z.
Z-score.
Yeah, because it is its own z-score. Because if you subtract 0 and divide by 1, you don't do anything. Do you see? So if I give you the value on the axis, on the horizontal axis, that is the z-score if it's a standard normal distribution. So the first thing is that we're going to write z, and I'm going to use this. And I'm not sure if you've probably seen that symbol before. It's on every keyboard, right? Who knows how to say that symbol? What's the name of that symbol after that Z? It's something they don't teach anymore. I don't know. I learned it when I was a kid. For some reason, I think they stopped teaching, even though it's like on every keyboard. You look at your keyboard. I don't know if you're looking at a keyboard right now. I bet you can tell me every other symbol, or just about. There might be one. The Shift 6 you may not know. Okay, this one is called tilde. So it's a tilde, and what it means is has the distribution of. Then I'm going to put an N. What do you think N stands for? Not a
Normal?
trick question. Yeah, normal. And then 0, 1. And the reason why 0, 1 is the first number is a mean, and the second number is a standard deviation. So if you have the standard normal distribution then the variable we use is z, and it is tilde n01, which means that it's normally distributed between 0 and 1. It's not between 0 and 1, with mean 0 and standard deviation 1. Okay, we've also talked about uniform distribution, and those two numbers are your left and right. But when you're talking about normal, your two numbers are the mean and the standard deviation. And you're going to be required to write this kind of symbols, so get used to it. It's not hard, but you have to think to do it. Any questions so far? Okay, so let's do an example. Find the probability that a standard normal variable will be larger than 2. Wait, no calculators allowed. This is the only time I'm going to say that. Okay, now I'll let you, if you need a calculator for basic arithmetic, because your arithmetic skills aren't that great, that's okay. But otherwise, no calculators allowed. How can we do that? Any suggestions? So 5% is a really good guess, but you're off by a little. So let's take a look at the picture. We know that the probability that it's between -2 and 2 is 95%, or 0.95, right? So I like to think of the inside is 0.95. So if the inside is 0.95, we don't want the inside. We want the the right. Does that make sense? We want this area over here. So if the inside is 0.95, the outside is 0.05. So note the inside. So it's between -2 and 2 is 0.95. So the outside is 1 minus 0.95, which is 0.05. Any questions on that?
Yeah, what do you mean by the outside?
Okay, so the inside is everything in here where the arrow is. Do you see the arrow?
Yeah.
So the outside means everything to the left and to the right. So think of this arrow, these blue guys. Think of these blue guys as like the walls of your house. And everything in here is warm, you're inside, you got the heater on, got it? But if you're over here, or if you're over here, then you're not inside. Do you see that?
Yeah.
Okay, now we don't want the full outside, we just want the right-hand side. Do you see that? So, but we know that the normal distribution is symmetric. So if it's symmetric, then if you take the right-hand side is equal to the left-hand side, which means that two of these guys will give you 0.05. So the probability that z is greater than 2 will be half of that, or 0.05 over 2, which is equal to 0.025.
So we're saying that the standard normal variable is the same as a z-score right now, right?
Yeah, and it is just because whenever you have a mean of 0, standard deviation 1, if you calculate the z-score, you get the same answer.
Yeah, because you could
Like-
look at that graph, substitute all the mean symbols for zeros, and substitute the
Sigmas for 1.
beta for z,
Mhm.
and that would probably be more logical with the question.
Yeah, or even easier, just read the black part and ignore the red. So you
Oh.
see the -3, -2, right? 2 and 3. I think that's the easiest way to see it. Unfortunately, when I went online to look for a good picture, they only had the general picture. And we're going to talk about that next. Any questions on this so far? Okay, so I wanted to give you the idea of getting used to kind of seeing areas, insides and outsides, and because we're going to be using that throughout the quarter, especially when we do confidence intervals and hypothesis testing, which is most of this class actually. So it is important to get these ideas. So that's why I did this example. Even though you could do this with a calculator, but I wanted you to get the idea. And I don't care whether you can divide 0.05 by 2, but I want you to be able to visualize this distribution. Okay, so now let's go to the just general normal distribution. So first thing is general normal distribution is unlike the standard normal distribution, the mean and standard deviation could be whatever's given. So whatever numbers they give you, the mean could be 100, standard deviation is 10. Do you think that's ever used? Any guess? The answer is yes. IQ scores have a mean of 100 and standard deviation 10. So if you have a standard deviation more than 120, then, an IQ score more than 120, you're an outlier. Is that clear? Because you're more than two standard deviations above the mean. So, and IQs tend to be pretty normally distributed. Not perfect, but it's pretty normal. It's pretty normal. Okay, so the general normal distribution is the same idea, except the mean and standard deviation don't have to be 0 and 1. They can be other things. So let me give you an example. Find the probability that a randomly selected person will have an IQ score greater than 107, given that the distribution of IQ scores is normal with mean 100 and standard deviation 10. Any questions on the question? I call that A. As you might guess, it's coming after A, right? B. But for now, we'll do A. So the first thing I want you to be able to do is write down the distribution. I'm going to give you about 4 seconds, shouldn't take longer than that, to write down the distribution using symbols like I did. The hint is one of the symbols is tilde. So it shouldn't take more than a few seconds to do, and then I'll do it. Okay, hopefully. Okay, first thing, it's not a Z, because this is a general distribution. So typically, what letter do mathematicians use for general stuff? You should all know this.
X.
X. Yeah, X is the standard letter. Yeah, and sometimes capital, sometimes lowercase, I don't care. So X tilde, actually Microsoft, it wants it capital. X tilde N 100, comma 10. And that's the way of writing down what the distribution is. Okay, so there are 2 ways of finding this probability, right? First thing, let's write down, it's always good in symbols. We want the probability that X is greater than 107. Any questions on what we want? Okay, so one way of doing it means that for most of you need to take about 4 or 5 years of math, get to graduate school and be a mathematician, and then you can do it. Okay? You don't need to do it that way. Instead, what's the easier way?
Calculator.
Yep. So let me show you the calculator. And I noticed some of you are asking, what's the link to the calculator? So if you go to the syllabus, there's a link to this calculator. That's the easiest way to find it. And then you can find this calculator. If you go to the syllabus, scroll down until you see calculators, and that link is right there. Just let you know if you're looking for the link and can't find it. On your exam, you won't need the link because it'll be embedded into your exam. Just let you know how that works. All right. What number do you think I'm going to use?
8.
Yep, 8. So you notice we're in order. We've already done binomial. Now we're on normal. So I click normal. Okay. So what it's going to ask you, let's read the instructions. It says fill in all the values except 1 below and hit calculate, and then the last value will be given to you. Okay, do we know the low?
100.
Let me go back. So we want the
10.
probability that X is greater than 107.
107.
107. Is that clear? Okay, what is the high? What's the highest number that's greater than 107?
Wait.
130.
Okay, you say 130. What about 131? Is that bigger?
Yeah.
Okay, so you're not there yet.
Infinity, because we don't
Yeah,
know.
infinity is the answer. Okay, but you can't, but that's not a number. So what you do with a calculator, not just my calculator, but any calculator, is you put in a bunch of 9s, and I recommend 2 or 3 more 9s than the number of digits of the biggest value. So here we're looking at 3-digit numbers. So 5 9s should do it. You could do 6 9s if you want to. Won't make any difference. Any questions on that? What's the mean?
100.
Yep, the mean is 100. What's the standard deviation?
10.
Yep. P equals, do we know?
That's what we're trying to find out.
Exactly, so that one we leave blank. Got it? And then I hit calculate. And we're looking at, I'll just copy and paste this. The way I program this calculator is it's got way more decimals than you'll ever need in life. But copy and paste is easy enough. Or about 24% chance. Any questions on that? Okay, just note when you're doing the assignments online, you know, the computer graded assignments, my recommendation is keep at least 4 decimals if you can. You could always do more. If it asks for 3, you can do 6 and it's okay. On an exam, so on the exam in, you know, a couple weeks, as long as you show your work, I don't care how many decimals you keep. Got it? So that's kind of the rules of the class. Any questions on part A? Okay, part B. Find the first quartile. For IQ scores. Okay, now the distribution hasn't changed, but I'm going to put it there anyway, because you're going to have to on the exam, at least the second exam. So X tilde N 110. Now, what does it mean? Who remembers what first quartile means?
Top 25%.
Quarter.
Yeah. So what do we know about a quarter or 25% or 25th? What is that? Let me
There
go
are
back
4 of them.
in our calculator. What is that?
The probability at 0.25.
Yeah, that's the probability. Because that tells you that 25% of the area is to the left, or there's a 25% chance of being less than the value we're looking for. Any questions on that? So in this case, P is 0.25. Okay, the mean and standard deviation here haven't changed. Do you agree? We're still talking about IQ scores. Okay, the low and the high. What do we know and what do we not know? Because obviously the one we can't, there's got to be one thing we don't know.
Don't know the high.
The high.
Yeah, we don't know the high, so I leave that blank. What's the low?
0.
You could do 0, or because it's a normal distribution, we're assuming it's normal, it goes down to negative infinity, goes all the way left. So negative 99999. Any questions on that? Then we hit calculate, and there's our IQ score in the 25th percentile, which is about 93. Any questions on this example? Anyone lost?
I am.
Okay, what part you get lost on?
So why would you choose the low as the negative infinity? I mean, why wouldn't it be 0?
Okay, so let me go back to the picture. So here's our picture. Do you see that?
Yes.
Now,
Yes.
if you're in here and you are below the 25th percentile, in the picture, how far can you walk? To the left. And the answer is forever.
Forever.
Oh, I see.
You see
Okay.
that?
Okay.
Now, we're assuming it's a normal distribution. Okay. I don't think anyone really can have a negative 10 IQ score, but since we're assuming it's a normal distribution, then it can theoretically happen at almost 0 probability. And just a note, in this case, but you have to be careful about this. If we put 0 instead, so remember this high was 93.255. If I put 0 for the low, do you see any difference?
No. Oh, 90 point.
No, it's still
No.
93. No, it didn't change anything. And the reason why it
Alright.
didn't change anything is, let's look at this. 0 is 10 standard deviations below the mean. How many do you need for an extreme outlier? How many standard deviations below?
2. More than 2.
2 is for an outlier. Extreme outlier is 3.
3.
10 is ridiculously small. Does that make sense? So out of a trillion people, and there's never been a trillion people, you still wouldn't even have 1 in a million chance of having someone with an IQ score of 0.
So you put the negative number just to accommodate.
It's just safer.
Okay.
It's just safer. Because when you have the word less than, which is what we're looking at, negative 99999 is less than, is less than as you'll ever get. Does that make sense? Whereas a 0, you got to think about it. But with a bunch of nines, bunch of negative, bunch of nines, you don't have to think about it. That's so far below, it's no problem. Do you see that? And it turns out so is 0, but that's not always true. Does that make some sense?
Yes, sure. Tricky, but yes.
By the way, if you leave the mean or the standard deviation blank, I want to warn you. I actually learned something about statistics when I wrote this calculator. You don't get a unique answer, so you might get a different answer, but you'll never be asked a question to find the mean given everything else, or the standard deviation given everything else. But if you want to have some fun, you might get a different answer than you would expect. And there's some cool math that it's too hard for me to explain. But I proved it when I couldn't understand why the calculator was giving me the wrong answer. And it turned out it wasn't. But in this class, you're either going to leave the low, the high, or the P blank. Any questions on this example? Okay, let me give you another example. Let's see where I am. Okay. Oh, by the way, on your exam, it'll often ask you these questions. State the distribution. When I say state the distribution, where have I done that?
The 110 or 100 and then 10?
Okay, I've done it with the thing that has a tilde.
Yes.
Yeah, that's the state the distribution. Okay. Answer the question. That's this part. There, or in this case, I never copy and paste this guy. Let's do it again. That's good enough. Nobody cares about a 1,000th of a point of IQ, right? So the Q1 is equal to about 93.255, or about 93.
So you said state the distribution. What was the second part?
Answer the question.
Answer the question.
And number 3 is determine if the normality assumption was yet necessary. In this chapter, the answer is always yes. If you don't know it's a normal distribution, then you can't do anything we just did. You can't use the normal calculator if it's not normal. Does that make sense? Okay. So why am I even bothering with this part of the question? Any guesses?
In the future, it won't be as clear.
Yeah, and not even the far future. Next week. So next week, for many of the examples, we won't need to assume it's normal. But this week we're not there yet. But I want to give you a heads up. So the answer, if it ever comes from something from this week, directly from something this week, the answer is that assumption that it's normal was absolutely needed, or it can't be done. Any questions on that? Okay. And I want to let you know something. What are the first 3 letters of assume?
ASS.
Mm-hmm. Yeah, so just let you know. In fact, a lot of people look at, let me write down this word. I don't know if you've heard this before. You heard that before? Okay, so is assuming a good thing?
No.
No, it's a bad thing. Okay, but the good news is next week, we won't have to assume for most of the examples. And in the real world, you never have to assume. Okay, as long as you do things right. So this week is a little fictitious because we're going to always have to assume, but we're going to move forward next week. So I want to let you know that you never want to assume something. Assume means you say it's true, even though you don't have proof that it is. That's what assume is. Okay, any questions on that? Okay, so let's do one more example and then we'll call it a day. Again, we're not going to take a whole hour and a half this time because there's not much material to do. So there's a fun little example. It's kind of my favorite one in this chapter, or I made up. Okay, so any of you in the healthcare industry or want to be?
Yes.
Okay, so let me give you one that you may not know and you may know. Okay, suppose, so a woman is due to have a baby in 120 days. Okay. And I'm not going to get into how you know it's 120 days, but hopefully you understand sex. Okay. I won't go more than that. Okay. So a woman is due to have a baby in 120 days. Does that mean the woman is going to have a baby in 120 days?
No.
No.
No. Might the woman have a baby in 400 days? This baby?
No.
Hopefully not.
Not
No, that's not going
400.
to happen.
I mean, they
But-
would induce labor at that point.
It wouldn't even get to that point. No, that baby, the women wouldn't be alive at that point. Okay, so no, it doesn't happen. Okay, now we're going to assume that we're not going to induce labor. Okay. Okay, so we're going to assume that that's not going to happen. Okay, now it turns out, and this is a biological truth, the time to have the baby is normally distributed. Okay, with mean, you should all know what the mean is. What's the mean in this case? This is
120.
Huh?
38 weeks.
In this case, 120 days. That's what it means to be due in 120 days. Do you believe that? 120 and standard deviation. Now, this is something you may not know. If you're in the healthcare industry, you might. Anyone know? What is the standard deviation for delivery time?
40 weeks?
What's that?
28 weeks.
40 weeks?
40 weeks? That would mean that like 32% of the mothers are going to be 40, or 16% of mothers will be 40 weeks late after their due date.
Oh, no.
No,
28 weeks.
they're not going to be 28 weeks late either.
Typical- No. Oh, late, but
Late, yeah. Okay, it turns out it's 7 days. It's kind of cool. It's just coincidentally, it's 1 week. And that's the standard deviation. Okay, and I didn't make this up. I looked this up from, I don't know, some National Institute of Health or something. Okay, so here's the deal. Okay, the woman has an important job. I'm going to take career. That involves travel. Okay. If she is leaving the country today, and coming back in 110 days, what is the probability that the baby will be born abroad? Let's do the following though. Let's call that A. All right, how do I do this? So y'all understand what it means to be born abroad, hopefully. By the way, do you think it's a good thing if it's born abroad while she's traveling for work?
as long as you were planning on it.
No, it's not a good thing. It's just a bad idea. Okay, you're away from your doctor, you're away from your hospital. The baby can't be president. Not born in America, can never be president. Okay, so there's all kinds of things that are bad
you're
You
born
know.
on a flight, you get free. You get to fly for free the rest of your life.
Yeah, don't do that.
I've had a baby born abroad.
Yeah, it's a bad idea. It's a bad idea. So anyway, what is this probability? Well, let's start out as we've done before. X tilde. What I put? What letter?
N.
Good. Good. It's always going to be N for this chapter. What's the first number?
120.
120. That's the mean. And what's the second number?
7.
7. Okay. So this will really help because it will help you with the calculator too. Because now we know that the mean is 120, standard deviation 7. It gives you all the information you know from these long sentences. And we want the probability. Okay, if it's born abroad, that means that what do we know about X?
It's within the 110 days.
Yeah, so it's less than 110. Is that clear? Because the baby's born before day 110, baby's born abroad. If the baby's born after that, the baby's not born abroad. So what do we do next?
Calculator.
Yeah, we go to our calculator. So our mean was 120. Our standard deviation was 7. We want the probability, so that's what we don't know. Is that clear? What's the high?
110.
And what's the low? Officially?
Negative 9999.
Yeah, even though negative 9999 can't happen, it'll turn out to be the same as 0 anyway. And then calculate. Okay, so about let's round to the nearest percent, about 8% chance. So I know some of you want to have that baby on the airplane, but it's not a good idea. You want to be in a hospital, I'm telling you, in case if things go badly wrong, you want to be in a hospital.
I was
Okay.
miserable when I had to fly. I don't
Yeah,
want-
it's a bad idea.
And how do you take into account, I mean, as far as healthcare field, I work with labor and delivery patients. There are so many variables that aren't numerical. I mean, depending if it's pre-nip, like their firstborn, or if it's their fifthborn, or how do
Absolutely.
we take into account all of these different variables?
Right. Remember, what's the first name of this course?
Statistics.
No, that's the
Elementary.
second name. Yeah.
Elementary.
Elementary statistics. What do we not do? Advanced statistics. So that can be done, but you need advanced statistics to be able to do it. And I can't talk about that. It's just too much.
Okey-doke.
But you can get into that, and it needs to be a multidimensional analysis. I'm just not going there. Got it? I can only do so much. Okay.
No,
especially-
I appreciate that. I'm just
Yeah.
just
But
for
yes, it
further
cannot-
thinking.
It can all be done. Okay. But not in this class. Just let you know. Okay. So part B. Okay. You decide, or actually, I don't say you, she decides that there's a bad idea. It's too high a probability. This is a major life event. Okay, and she wants to be with her rest of her family, and okay. On the other hand, she doesn't want to quit her job either.
We want the pain drugs.
Yeah, you want the pain drugs. There's all kinds of things you want. Okay, it's too high a probability. Okay, so it's time to negotiate with the boss. Okay. Now, what do you think a probability would be that wouldn't be too high?
3.
Okay, we'll go for 3. So she negotiates to have only a 3% chance to have the baby abroad. Any questions on kind of what this means? Okay, when must she return home? Any questions on the question? Okay, now I'm going to copy and paste. The nice thing about this chapter is this isn't going to change. X is still N127. That hasn't changed, right? What do we want now?
Probability equals 3%.
Yeah, so now we're given the probability, and that's P for probability, is equal to 0.03. And remember, 3% is 0.03, not 0.3. So you always want to make sure that you move the decimal over 2 places. Okay, so we're given that P is 0.03. What are we looking for? Looking for the low, the high, the mean, or the standard deviation. Those are
The
A high.
Yeah. So I'm going to write for now, high equals, we don't know. Any questions on part B? Okay, so now I can go to the calculator. Pop in what we know. The low is still, you can use -99999. The high is what we don't know. The mean and standard deviation haven't changed. But our P now, 0.03. Any questions on that? And we hit calculate. So instead of returning in 110 days, when should we return? When should she return?
106 or 107 days.
Yeah, and if you understand negotiation, you go for 106. And then you might want to be flexible to 107, but you ask your boss for 106, right? So the answer is she should ask her boss to allow her to return home in 106 days. Any questions on that? Okay, which is 2 weeks before the baby's to be born. All right, part C. All right, so here's what happens. So she flies abroad, returns home, without delivering the baby. And still is pregnant on day 108. Okay, and that can happen, right? So 108 days has passed and she's still pregnant. What is the probability that she will deliver the baby in the next 24 hours? Any questions on the question? Okay, so this is asking for a probability. And the next 24 hours is what days?
1.
109, 1010, 110, I mean,
Um,
right? What do you mean? The
yeah,
next day?
so it's day one. It just started day. When I say it's on day 108, that means the very beginning of day 108. She's not pregnant. So it means that 108 is less than X is less than 109. Because those are the 24 hours after the turn of day 108. Except we're not just looking for that probability. What's the other issue? And the issue is she hasn't had the baby yet. So we have information now. And the information is that she did not deliver the baby in the first 108 days. So it means we're given information that X is greater than 108. Because if she's still pregnant, then there's a 0% chance that she's going to deliver the baby in day 90. Because she didn't. Is that clear? How do we solve this?
It's gonna be the probability of 108, the less than X less than 109 over the
Good.
probability of X less than 108.
So we get a fraction. And we have the probability that X is between 108 and 109. Oops. Divided by the probability that X is less than 108. Because that's the given formula. Okay. So, and by the way, for both to be true, to be between 108 and 109, and to be greater than 108 is the same thing as being between 108 and 109. Is that clear?
Do you say that one more time?
So the probability of being between 108 and 109 and being greater than 108 is the same as the probability of being between 108 and 109. This and greater than 108 doesn't tell you anything new. Okay, so if I tell you that I am between 50 and 60 years old, and I'm greater than 30 years old, what do you know about me?
You're over 30 and
Well, I'm
you're
over 30, but
Between the ages of 50 and 60.
You're between 50 and 60.
right. The and over 30 didn't help at all, did it?
no.
And that's what this is that we're greater than 108 and we're between 108 and 109. Well, that's the same thing as being between 108 and 109. Because the numerator is supposed to be an and, but I can ignore that greater than because that already happens in this equation. So now I have two things I have to do. So I'm going to write another fraction. And let's do the probability that we're between 108 and 109. Well, that means the low is what?
108.
108. The high is?
109.
109. And P equals is the one we don't know. And we calculate. And I'll just throw in a bunch of decimals. And then the probability that we're less than 108. So then we go ahead. What's the low?
Negative 9999.
And what's the high?
108.
108. And the P is what we don't know. And we get this number. Any questions on that idea? So then the rest is boring. So we just calculate. I wonder what'll happen if I copy and paste into Google this way. It didn't work. So that was the so 0.0148. And that was the numerator, and the denominator is 0.04323, etc. Yeah, I think I can copy and paste that. Let's see if it lets me. And you get about 34% chance.
But didn't we say that knowing that it's less than 108 or less than 108 didn't give us any more information? So why did we use it?
Oh, for the numerator, not for the denominator. So what I used, in case you don't remember, I used that the probability of A given B is equal to the probability of A and B divided by the probability of B.
Mhm.
Okay, so the A and B means both of these guys are true, but that's the same thing as just the first being true. But the B we need to put there. And that's X less than 108. Do you see? So that's still there. The probability of A and B is the same as the probability of A in this case. Not in all cases, but in this case. Does that make sense?
Oh, I think so.
Yeah, so that's using this formula. Okay, so 34% chance that she's going to deliver in the next 24 hours. Probably a bad time to, take a flight. Any questions on this example? Okay.
Hey,
Well,
Larry, when they're putting in the numbers into the calculator,
Mhm.
how many decimal places should they go to?
a lot.
Just as many as possible?
Yeah, as many as possible. Especially if they care.
Okay, thanks.
Okay. If it's just for fun, or you're just practicing, then it doesn't really matter. But if it's important, then a lot. If it's for the exam, you don't have to do a lot. What you have to do is show the work. So if you just do two decimals on the exam, but you show the fractions, then that's good enough. You get 100% if you can do it right.
Right, but no, like during the homework to get the correct answers, they're gonna have
Yeah,
to
during
put
the
in-
homework on the computer, a lot. I do like 6 or 7 probably.
Okay,
The final answer is 3 or 4, but there's error that happens past 3 or 4 when you're doing arithmetic, and that's kind of too advanced. I don't know if you've even seen that, probably, but it does happen.
I
Oh,
realized
wanna
that when I was on
mention-
homework.
I do want to mention, because this was a problem for some of you for last week's stuff, is that never use commas in numbers on the computer. So if it's a million, write 1,000,000,000. Do not write 1,000,000,000, or the calculator doesn't work. And for the expected value one, because there were a few people that had trouble, actually put instructions there today, or maybe yesterday, but I just put them there. So don't use commas in numbers.
What is the secret word, Larry?
That's what I'm about to do. I was going to do
Thank
it, and then there were questions. That's why I was scrolling, because it's way down here. And there it is. So the secret word is unimodal, because the normal distribution is a unimodal distribution that has one mode. So that's our secret word. And we're definitely finished early. I promised you we wouldn't take a full hour and a half. We're at an hour and 20 minutes, but we're definitely done. I'm going to stop the share. And I'm going to stop the recording too.